We'll be solving a system of linear equations by substitution. Now, if you notice that I have two equations, that is what a system is. In mathematics, in algebra, the system just means two or more equations. So I see I have two equations here. Now, sometimes there will be a bracket here, which means that these two equations go together, and that just means it's a system. We're going to solve it by substitution. Now, our substitution is taking one equation and substituting it into the other. And we've done that a lot in like smaller when y, say if it was y equals 3 without the other x and the minus 4, you would normally just take that 3 and put it in for y and then do your multiplication and then subtraction or solve for x. And that's what we're going to be doing here, just it's a little bit more complicated. So if we take and look at this section right here, 3x minus 4 is the y. So we're going to take that and substitute it in like we were thinking about just a minute ago and substitute it in wherever there is a y. So that 3x minus 4 goes in that position for the y. So what we do is rewrite the equation, so this second equation, and I'm going to put a parentheses for my y part. That's this part right here, the y. Bring down my equals and bring down my 10. Now that 3x minus 4 is going to go right in that position for the y. So wherever it is, it's going to go in that y position. So it's in front, the y is behind the 2, which is multiplying. So that's where I put that 3x minus 4. So now I'm going to solve for x because I just have x's. So I'm going to put these two x's together. But before I do that, I'm going to add the opposite, then distribute. Ooh, I have another add the opposite here so I don't lose my negatives. And I'm going to distribute that times negative 2 to both of those terms. So bring down my 5x, bring down my plus. So negative 2 times 3 is negative 6x. And negative 2 times a negative 4 is a positive. 2 times 4 is 8. Bring down my equals, bring down my 10. So now I'm going to combine these two x's. So negative 6 plus a 5 is a negative 1x. Ooh, it's close to being by itself, but it has that negative 1. So I'll have to deal with that in a little bit. Plus 8, bring down my 10. Then I'm going to, oh, it's just a two-step problem now. So I'll solve by getting the 8 over to the other side. Bring down my negative 1x equals 2. Divide both sides by a negative 1 to cancel out that times negative 1. And x equals negative 2. Now, here is where we normally would just stop, but because it's a system, and if I think about that system, we've done some graphing with this. So here's my thinking. I'm kind of doing a thinking bubble. So I have this graph, and I have my x and my y-axis, and so this 3x y equals 3x minus 4 is going to be something like this. It's a positive slope, so it's going up. This one's going to do something. I don't know what it's going to do. Maybe it's a negative slope, but it's going to be some other line, and there is my solution. So the solution, well, we call the solution, most people, oh, it's just right there, the answer, is where both of those lines, both of these equation lines meet. So our answer is a coordinate pair because that is a point on a graph. So if we start off with that thinking this x equals 2 that we got at the bottom here goes right here. So now we notice that we need a y. So to find the y, we go back to our original equation. We can do either of them because that point is on both lines. So I'll probably choose the first equation because it seems a little easier to do the multiplying. So I'll copy that down, y equals 3x minus 4. And then that negative 2 which is x, gets substituted in for the x in that equation. So y equals 3 times, notice how I'm using a parentheses to put that -2 in, so I get that multiply here. If I leave the parentheses out, it's going to be 3 minus 2, and we want it to be a multiply here. So 3 times -2 is a -6. Bring down my y equals. This is where it gets tricky. So I'm going to change that subtract 4 to a plus a -4. So I get the right calculation of -6 plus -4 is a -10. So that now is my y coordinate, part of the coordinate. So the point where they cross is -2, -10. So my graph is a little off. It should be down here where they cross. But what's interesting is that the concept, so this is just the thinking part of it, but the concept of that is that it crosses at that point and we just have to calculate it. So that's when it was a y equals, or one of the equations was a y equal. For our second example, we're going to look at this system, and you notice, I'm going to put a bracket, meaning that is a system, meaning where do they cross? So there's going to be some graph. It's going to do something like this. I'm not sure what the graphs look like, but I'm going to find that coordinate pair. So I'm going to start with that first this time, so I know this is my answer. Now I'm going to go find those numbers to put in there. I need an x and a y. So for this one, I see that my x is by itself. Now I know I have this feeling that I want to solve it for y and then do the substitution because I love that y equals mx plus b, 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 and it helps me think about what for the graphing, but for substitution, you don't even have to do that. You just need one of the variables, x or y, by itself. And I have the x by itself, so I'm going to take that 6y minus 7 and substitute it. Now, this is the tricky part. Because that is the x, I'm going to draw my arrow to the x variable. So that's where the 6x or 6y minus 7 is going to go in place of. So I'm going to rewrite that 4, and I'm going to leave a big space for the x plus y equals -3. Now I like to write that second equation first, get it all down with a big space to put that 6y minus 7 in that position. So now we're going to distribute that times 4 to both the first term and the second term. So 4 times 6 is 24. Y negative 4 times 7 is 28. Bring down my plus y, bring down my equals, bring down my -3. So notice how I'm bringing everything down, and we're going to solve for, I see we're going to solve for y this time. So now I have 1y plus 24y, so that would be 25y minus 28 equals -3. So, now it's just a two-step problem. So I'll add 28 to both sides. I'm seeing a nice number here because that's 25 equals on the right-hand side, and I've got a 25y on the left-hand side, so those numbers work out nicely together. There's my y equals 1. So now in my y position, we've calculated out a 1. So what do I have to find? I need to find the x. So x comes in place for these two equations. So either of them work. So I'm going to use my easier one, x equals 6y minus 7. So that y equals 1 will go, the 1 will go in for the y. So x equals 6, and see how I'm substituting in a parentheses the 1, because that's the y, right below it. 1 times 6 is 6. X equals 6 plus a -7. So notice how I switch to adding the opposite so I get the correct calculation, because if I don't want to put a 13 there because it calculates out to a -1 as our x. So that x is then this part of that coordinate pair. So these two have to go together into a coordinate pair where it will cross, those two lines will cross. So to check our answer, what we do is we substitute this coordinate pair in for both, because we want to find out if we made a calculation error in here somewhere. So what will happen is if they both check out to be correct, both equations, when we substitute them in up here, then we know that they are true for both of them. So I will substitute the x in for with a -1 equals 6 times my y, which is 1 minus 7. So -1 equals 6 plus a -1, and that does figure out. And that's the easier one because we used it right here. So we want to check that other equation just to make sure that it is true for that one, because that's where the error will show up. So 4 times x, which is our -1, plus 1 should equal -3. So that would be -4 plus 1 equals -3, and that does check out. Great, so that means these two checks mean that this coordinate pair makes both of these equations true, which means that that is the point of intersection where they cross. If one of these had said gone as a x, like it didn't work, then we would have to go back and find, it was probably a negative, maybe distributive over here, or when we added and subtracted a negative, we might have, that's the first thing I would look for, and then a calculation error, maybe a plus minus somewhere else. But for this one, they both check out, so that is our solution to our system.